Good day, welcome to your next coding challenge entitled Almost Palindrome. A string is an almost palindrome if, by changing only one character, you can make it a palindrome. Create a function that returns true if a string is an almost palindrome and false otherwise. The notes are that you should return false if the string is already a palindrome. So that's good to consider. They want exactly off by one character. So there are some examples. You can see that the first one returns true. They're only off by the very end letters, the A and the G. If you change that G to an A, then it would be a palindrome. I don't think I have to talk a lot about palindromes. We've done so many palindrome challenges with strings and numbers that concept's probably clear by now. Number 2 returns true. Notice the second character, B, with the letter I. Those are off, right? Those ones don't match, but the rest of the characters do match. So we're good there. And the final example is false because the A's match, the second letter doesn't, the third letter doesn't. So we've already missed on 2 characters, and so that will be false. It's not an almost palindrome. It needs to be off by only one letter. So we should be good there. We can head over to code, and you know the drill. You pause the video now, you implement this, come up with your own solution, and resume when you're ready. So for mine, I'm going to make basically a variable to hold the number of what I'll call misses that I encounter. I'm going to compare strings from the front and the back, starting at the outermost points and moving inward toward the middle, and basically increment a miscount while I'm doing this. By the end of the loop, I can return that count, or return if that count is equal to 1. While I'm processing the entire string, if I go over 1 for my miscount, I'm going to break out of the loop and sort of short circuit out, because once we have 2, we can end processing, right? You're only going to encounter more, and 2's already fails the test, so to speak, so there's no point to continue processing a long string. So we'll call that a mini optimization. So let's make that local variable. Let's call it num misses, and we'll initialize it to 0 to start. We haven't processed anything yet. I'm going to make a simple for loop to iterate over the string. I is less than string dot length, and I'm going to use the length over 2, right? Because I'm grabbing 2 characters with each iteration. I'm grabbing the outermost characters, so I only need to process half the string, right? And then finally we'll increment. Okay, so in our for loop we're going to check that the current letter pairs match. This would be done with string I, which will start at the very first letter, and if we say if it's not equal to its corresponding character on the other side, it should be string length minus 1 will give us the last element. Remember, if we just had length, that would be 1 beyond the array, and that would be an out of bounds access kind of thing. So we got to do minus 1 to get to the end element, then minus I. So in the case of the first iteration, I will be 0, and this will leave us with length minus 1, which is the last element. It'll compare the first element with the last element, which is exactly what we want. And then as I gets incremented, this will start moving from the front to the right. This is moving from the end of the string to the left, toward the front, and they'll meet in the middle. This is integer division, so if you had a length like 7, it'll go down to 3. 7 divided by 2 is 3.5. The half gets discarded and you're left with 3. And you can visualize that. You're taking 3 characters from the front, 3 from the back, and you don't care about a string being in the middle because it automatically matches. There's nothing else to pair it with, so it matches itself. So anyways, if we compare a couple of the characters and they don't match, let's increment our number of misses. And then at this point, we can check if num misses is greater than 1. This is that short circuit thing I was talking about. There's no point in continuing. We already know it loses. It's going to fail. We can simply say, hey, break out of this loop. The break statement finds the enclosing scope, which is these brackets right here associated with the for loop, and it will break out. It essentially terminates the loop. You know, let's say you had to go up to 3. We had our example of the string length of 7. It was going to go to 3. If you were on I equals 2 and you had gotten to this point, it'll just terminate the loop early. That probably wasn't a good example. Just imagine a much larger length, and yeah, this will break out. Exit early. So at this point, right, it's as simple as checking our number of misses. The instruction said we had to have 1, precisely 1. 0 does not cut it. A palindrome does not work here. That should fail. So let's return num misses is equal to 1. I think this covers us. We did all basic stuff. We don't need to bring in any libraries for any of this. Check it. And yeah, that's looking good. So, yeah, pretty basic strategy there. Hoping this one was pretty easy for you, given all the stuff we've done with palindromes. But if not, feel free to hit me up with those questions. Otherwise, we'll see you in the next video.